Hello everyone, let's dive into the web user interface of Spectroscape. Section 1, the Force-Directed Graph. This is the main page. For each query spectrum, we can use the search button to obtain its approximate nearest neighbors, ANNs, from a spectral archive and plot the neighborhood as a network. The query spectrum is identified by a unique query ID. We can use the previous and next buttons to search for previous and next queries. The random search button will jump to a random query. Let's click the search button now. The force-directed graph is responsive. Hover your mouse over a node or edge to see the corresponding information. Click a node to view its peptide spectrum match, PSM. We can adjust the number of ANNs returned by Spectroscape and the number of buckets to look into. For graph node parameters, we can change the node size and coloring strategy. By default, a node is painted with a non-black color if it is identified with a 1% FDR by a search engine. Unidentified nodes are colored black. The color of identified PSMs is determined by a hash function, ensuring that the same peptide has the same color across different searches. We can also color nodes using group IDs. Distinct group IDs are assigned to each peptide but are reused in each search. Therefore, the same peptide can have a different color if its group ID changes. By default, Spectroscape uses peptide sequences to color nodes, ensuring that the same peptide always has the same color. The group ID coloring method is also helpful in rare cases when two peptides hash to two unique colors, but they are so similar that the human eye cannot differentiate between them. In the graph edge parameter settings, the maximum allowed Euclidean distance can be changed. The default Euclidean distance is 0.8, equivalent to a dot product of 0.68. When increased to 1.4, all nodes are connected pairwise. When decreased to 0.0, all nodes become isolated. We can improve the visualization of many isolated nodes by adjusting the gravity and repulsive force. Gravity attracts all nodes to the center, while repulsive force pushes nodes away from each other. The connectivity parameter allows us to use either network or star style to visualize the graph. Edge width can be changed, and we can see edge information when hovering the mouse over an edge. We can map nodes onto concentric circles based on their dot product score with the query node. Each circle corresponds to a dot product score, with smaller circles representing higher dot product scores. Each node is assigned an orbit corresponding to its dot product score. For our native PSM viewer, we can turn off the annotations for neutral loss peaks. Line width and font size can also be changed. The default noise level is 0.01, which means that peaks with intensity less than 1% of the most intense peak will be ignored. We can also change the mass tolerance, which is set to 0.02 by default. The x-axis range can be determined by the m/z range of the peaks. Spectroscape can plot PSMs using either all raw peaks or only the top 50 rank transformed peaks. Users can choose to use the well-known Lorikeet tool or our native PSM viewer to plot PSMs. We have another video about our native butterfly PSM viewer. Section 2, Nodes and Edge Tables. We can see the list of ANN PSMs for a given query spectrum. The PSMs can be filtered using the search box. The edge table displays the mass and retention time differences between two connected nodes, helping users deduce the potential post-translational modifications. Section 3. Searching for peptides and files. We can use the peptide search page to find PSMs corresponding to specific peptides. Click on one of the query IDs to start a new search. Here, we only support exact matches of peptide backbone sequences. If the peptide does not exist in Spectral Archive, the table will be empty. We can also search for PSMs from a specific data file. Spectroscape supports partial matches of file names. A scan range is required to return a selected list of PSMs. Thanks for watching.